Hello, WRAAP students. This is Dr. Smith here with you today. We are going to do an electrical experiment today. We're going to take lemons, as you see in front of me, and create electric current. We're going to measure the current using this meter, okay? So before we get started with this, I want to give you kind of a model from a kit that I had that I purchased a long time ago. It's let me get the kit. Electricity and Magnetism Kit here. I took a simple model, and just to show you kind of what we're going to do with the lemon today, interestingly enough, the battery portion, the part that has the actual current in it, is the same color as the lemon. So those two are going to be the same. And here you have two wires. Each wire, we're going to find out if there's actually an electric current by attaching each wire to this light, connectors on this light. And if there is a current, this light should light up. So let's see if it'll happen for us. And there it goes. Just like that. And you attach it. So we're going to, instead of having a light today, we're still going to figure out if there's truly an electric current, but we're going to use a meter instead. So we'll be able to monitor here. So as you're looking, as you get a chance to see this meter, it should not read 0. You should actually see some numbers here, okay? So I'm going to go ahead. I put 2 slits in the lemon. One is a nail, and it's not just a regular nail. It's not just a metal nail. It's what's called a galvanized nail. So it is wrapped in zinc, a certain type of metal. And then we have a penny. Most pennies used to be made of copper, but they changed that. A lot of the newer ones aren't made of copper at all, but they are made of a metal. Some, if you get older ones, may be made of copper and zinc or something like that. That would be an interesting fact for you to Google to see what exactly they're made of now. So what we're going to do is we're going to take our positive electrode and we're going to touch it to our metal here on the penny, and we're going to take the negative one and we're going to touch it to the nail and see how much electric current we have, okay? And we do have a current. All right, now we're going to compare the voltage of this lemon to that of an actual D battery. Now, as you can see, the lemon read 0.79, and the battery, the D battery, read 1.58. So the voltage of the battery is about twice the that of the lemon. So it tells us that we're probably going to need more lemons. So now, as you can see here, we have already hooked up a bunch of lemons to see how much voltage we could get with 1, 2, 3, 4, 5, 6 lemons we have, okay? So here we go. Are you ready? Mm-hmm. I am. And as you can see, the more lemons we added, the more voltage we had. We got up to 4.68 in voltage. And so that lets you know that with batteries, the reason you have bigger batteries, the more powerful the battery is, and the more voltage different devices need. So as you try this at home, if you try to get a little light to actually light the light up with something like this, you need to make sure that you have plenty of lemons available so that you can do that, okay? Now, I have one question for you. What vegetable do people usually use to do this same thing? So that is something that you can find out. So I expect you to use your internet skills and search and find what other vegetable, or what vegetable, because this is a fruit, what vegetable you can use to do this same thing. Now, we're going to go to the board, and I'm going to talk about what actually happened in the science, okay? Okay, so let's just talk about what we did in the experiment. We had a lemon. Okay, don't laugh at my lemon. We put slits in the lemon about an inch apart, and on this side we had a metal from the penny, and on this side we had a metal from the nail. And then what we did was we attached copper wire, which is, you know, a type of metal, copper wire to one side, and we attached copper wire to the other side, making sure that we made contact with the metal. Okay? And then from the meter, one side positive and one side negative, we had the meter here, and that's what measured our electric current. Now I know some of you you're like, what in the world, how does that even happen? Well, this is how it happens. If you looked at my acids or bases experiment, I did talk about how acids react with metals. So, in the lemon, there's acid. Remember acid? They'll react with metals. How they do that is the acid loosens what's called electrons. And when it loosens the electrons, they start to flow, causing the current. But the one thing that you have to make sure that you do is you have to make sure there's a closed circuit. That means if you were to take this wire off, then the meter is not going to read the same because you didn't close the circuit or close the loop up. So always make sure that you have a closed loop. Okay? Excuse me. Now, let's talk about what an electron is if you are like, okay, so you told me electrons are loosened. What is an electron? Okay, I'm going to tell you. So all matter, that means anything that's here in this world, a table, a notebook, we're all made of matter. And the smallest particle of matter is considered an atom. Now, how an atom is set up, according to what science tells us, is an atom has a center, and the center is made of protons, which are positively charged, and neutrons, which have no charge, zero charge. Well, the electrons that I'm talking about, they're negatively charged, and they're on the outside. And a lot of times you'll see in books, science books and everything, they'll have different orbits, as I like to call them, and they do too, for these electrons. And depending on how many you have, it tells you where they'll be. So electrons move along in here in orbits. And so just know that they're negatively charged. We're not going to go into too much detail because we're just getting started on this. Just know that they're negatively charged and they move around. So that's what's happening. The acid is causing those electrons in the matter here to move around, and they're reacting with all the metals. The penny has metal, the nail has metal, the copper, which is metal, in the wires. It's causing the electrons to move, and the meter picks up that current. So now, not just knowing that metal actually works with electricity, you actually know that if you take that fruit that has that lemon juice, which is acidic or an acid, it's going to loosen those electrons and get them moving, stir them up and make a move, and they'll create a current. That's all that is, okay? So I hope you all have fun with this experiment. Please, if you have someone who really likes to work with gadgets and wires, and maybe they're an electrician or that's something that they do, definitely seek them out to help, because you might be able to make a more sophisticated model. Okay? Also, don't forget to check and see what vegetable you can use to do the same experiment. And also, if you really get into this and you want to learn more, check out the Electricity and Magnetism Kit. It's pretty awesome. It comes with the laboratory notebook that helps you do experiments. But when you do these, if you really want to be in a lab, make sure you have your lab coat or your apron and your glasses. I have some here, but today I'm just wearing mine because, you know, I'm not really doing anything really serious. But you should always wear your safety glasses. And like I said, they'll have the lab manual. So that will definitely get you where you need to be if you're ready to be a scientist dealing with electricity, okay? So have fun. Feel free to let the WRAAP staff know what's going on, what you've done. We'd love to hear about it. But until next time, remember that it's important for you to exercise your mind as well as your body. And I'll see you soon.